And good afternoon, everybody. I'd like to thank everyone for joining me this afternoon. So as Laura said, this is an iLogic Quick Start webinar. And today, what we're going to end up talking about is actually a few things. We're going to talk about how we can utilize iLogic in creating a part. Also, using iLogic in our assembly. And then once we finish with creating some of the great iLogic code that we are capable of producing in Inventor, we're going to take those into our drawing environment and see what kind of nice tricks and other options that we have utilizing the iLogic. So let's go ahead and get started with the part design aspect of our presentation today. First of all, I want to go ahead, and if you've never seen the iLogic within Inventor, I'd like to take just a few moments to give you a brief introduction. So first of all, what Inventor has, or actually iLogic has, is the functionality to take the use of parameters and equations in a model one step further by adding an additional layer of intelligence in your design. Also, iLogic enables you to set the criteria in the form of established rules that capture design intent, enabling you to reuse designs to suit various design scenarios. In addition, the rules that define the design intent control the model and automate the design workflow to ensure the model reacts correctly. Also, continuing on, we have where iLogic rules are based on conditional statements and functions. These automation functions have been embedded in the rule creation dialog box, enabling you to define the rules that can accomplish many different results in a design. And the great thing is about the iLogic, you know, people kind of start getting a little wary and they kind of stand back a little bit. But the great thing is no programming is needed to use the basic iLogic functions. In addition to that, we can take advantage of Inventor's capability of iLogic in the part, assembly, drawing, and sheet metal files. Next, you see on your screen, I'm wanting to show an example. So in this example, iLogic is used to control the thickness of this connecting rod based on its length. The rule that controls the geometry indicates the range of values that are acceptable and what thickness value is to be used. So for example, if we look at this and break it down with what we're seeing in our code, so what it's saying is if my length is greater than or equal to 60, or my length is greater than 80, so it's looking at a range between 60 and 80. And if my parameters match between this range, then my thickness is going to be 1.5. Continuing down, if my length is greater than or equal to 80, or my length is less than or greater than 100, then my thickness is going to be 3.0. And then also if my range is less than 60 or my length is greater than 100, we're going to see a nice little message box that pops up, and it'll say, please enter a value between 60 and 100 millimeters. Invalid entry. So moving along, next what we have is I would like to share with you the list of system functions that can be incorporated into an iLogic rule. The main thing here to take away is functions are the basis of every rule. Functions actually tell the model what actions to perform when a rule is executed. And also you'll notice over here to the right with our image that is showing, you can see that a substantial and varied list of functions are provided within Inventor. Next, I want to show you some of the examples of what iLogic rules can accomplish. So common uses, we can control model and user parameter values. We can activate part and assembly features, assembly components, or assembly constraints. Some more capabilities that we have with these functions are being able to update material and iProperty information. Also, we have the capability of measuring entities in the model. And then on the drawing side, we can actually control the size of our drawing, the borders, and title block information based on user entry. In addition to controlling the size, borders, and title block, we can also control the view location and the size of that view. Or we can also control suppression in a drawing. Now, when we start getting into the Inventor user interface and the iLogic user interface, there's general steps that we're going to follow in creating a part using iLogic. The first step is to prepare the model. Now I'm going to go into each one of these steps a little bit deeper whenever I am actually within Inventor. Number 2, we need to initiate the creation of the rule. 3, once that rule is initiated, we need to define that rule, which means we need to give it some kind of meaningful name. Then once we have defined our rule and started adding our iLogic code, we need to verify the rule and just make sure everything's working as expected. Then, if we have the need, we have the capability of setting event triggers. And then, if there are any additional rules, we just need to create those as needed. Now, for our goal that we're wanting to complete this afternoon in regards to the creation of a part utilizing iLogic, and it's also going to be what I'm going to demonstrate, you'll notice that we want to utilize iLogic to automate the geometry of this flange to meet the following design criteria. The first thing that we need to meet is, depending on the flange's number of ribs and outer diameter, the rib geometry automatically changes. So the outer diameter is to be selected from a list of 6 options from 50 millimeters to 100 millimeters. So what that's telling me now, it looks like that we might possibly have to utilize something at like a multi-list within our parameters. And then the number of ribs can be manually entered. In addition to that, we want to set up a rule that all rounds can be turned on or off with a parameter setting. And this could be for a possibility of, sending this part to our FEA capabilities with Inventor. If these rounded edges or fillets are real small, dealing with simulation, when we have small entities such as that, that can lead into long simulation time, waiting for the model to perform all of its calculations. Also, we need the model I properties change depending on the material selection. So we'll end up assigning certain materials to this flange depending on certain design criteria. Okay, so I'm going to jump directly into Inventor, and I am going to start the flange part. Now I'll be referencing back to those steps that I mentioned. So the first thing, or step one, was to prepare our model. So what that means is we need to make sure that if there's any parameters that we need to utilize, we need to ensure all the dimensions, parameters, and equations exist to capture our design intent. So we need to make sure everything is working as we want it to. Also, just double check your model and review the parameters dialog box that I currently have open. And then if there are any more parameters that we need to utilize, such as user parameters, we can go ahead and add those, and also turning any of these parameters into multi-value parameters. In addition to that, we want to go ahead and the parameters that we need to utilize are what controls our model to result in our current design intent. We need to go ahead and set those as key parameters. And then a good practice, as always, even when we're just sketching, is to flex our model by modifying parameter values just to ensure that it updates appropriately. Now, the next step that we had for number 2 was initiate the creation of the rule. Now, you're going to notice that everything that we need to do in regards to bringing up certain dialog boxes, so on and so forth, is going to be located in our Manage tab, and you'll notice over here to the right we have an iLogic panel. So this is where we're going to be spending our time today. So like I said, the first thing was to initiate the creation of the rule. Now, once this comes up, what we need to do is actually go ahead and give it something meaningful. I'm sure that you guys that are familiar with Inventor have been giving your parameters, meaningful names, so you'll actually know what you're going to be changing in your model if you come back, a couple weeks later. It's just a better way of, instead of spending time reverse engineering, just make your model more intelligent. Okay, so what we're going to end up doing now is we are going to, let's say, before we create this rule, there's one thing that I do want to do. We're going to go in and we're going to add a user parameter. So I'm going to go ahead and scroll down here to the bottom here, and we're going to add a parameter, and it is actually going to be, let's do numeric. And like I said, I like to go ahead and, give my parameter a unique name. So I'm actually going to call this flange underscore OD for outer diameter. And with one of our design criteria, we were asked that we add, let's see, we need to have a range from 50 millimeters to 100. So I'm going to go ahead and set that up. So I'm going to make this flange OD. I'm going to make it a multi-value. And I'm just going to go in and start adding my range from 50 to 100 in increments of 10. Okay. Once I have those entered, I'm just going to add those to my list, and I'm just going to come in here and verify that my little drop-down list did populate, so we can see that I have my multi-values applied. Okay, so once we have that, we are going to, I'm going to go ahead and select it to 70. Okay. So for this, we'll notice, and let's go ahead, and for those that are not familiar with the equations, currently, right now, this user parameter that I added, if I switch it to some of these other values, we'll notice that I currently don't have this equation or this multi-value list apply to anything. So actually it is not doing anything to my model currently. Okay. Now what we're going to do so that this actually starts to take effect is I'm actually going to link my user parameter to an actual model parameter, and let's see, I'm going to add it to flange outer diameter. Okay. So you can notice now that my flange outer diameter now equals my flange OD. So by me doing this now we have established a relationship between these two parameters. So if I go back down and modify my user parameter to 70, you're going to notice that my model starts to update. I'm going to go ahead and change it back to 50. So I'm going to go ahead and close my parameters dialog box, and now we're ready to initiate our next step, which is add a rule. Now for those, if you've noticed, I have a separate window down here. It's known as the iLogic browser. So this is just going to give me the capability of seeing the rules that I have created, and this gives me the ability to also to delete or edit those rules as needed. So for this rule name, I'm going to give it, let's say, the name of rib type. Now, once you say OK on giving this rule a unique name, this is going to launch the Edit Rule dialog box. And we're going to spend just a few moments, and I'm going to discuss, some of the tabs and windows that you see within this dialog. Now over to the left, this is where we are actually going to start gathering functions, or as you notice, this area is called snippets, and we're currently in the System tab. Now the great thing is, if I start expanding some of these functions here, we'll start seeing that we have a lot of different choices that we can select from. And the reason that they gave it the name snippets is actually, these are actually snippets of iLogic code, or you might as well say VB code, because iLogic is VB based. Now here in the Model tab, this is just a copy of our model browser that you are used to seeing and on the left. And then the next area over, you're going to notice that we have a parameters and a names tab. This is just going to give us the ability that if I had model parameters selected, that I can actually choose just by double clicking some of these parameters to add them down here to the bottom. This window down here is where all of our code and syntax is going to be taking place. In addition, if I needed to gain or pull from one of these features, I can select one of those, and I can go to the names and I can select that feature, because it's not going to give me the ability right here to double click to add it down at the bottom. So this is where we will be doing those selections. Okay, you'll notice that we have down here at the bottom, we have some day-to-day tools that we see in other programs, you know, such as cut, paste, copy, undo, redo. And then some that you're not probably going to be familiar with is the next area here. These are known as our conditional statements. So these are going to be how we start to tell Inventor what we are wanting our geometry to do. So with that, we're going to continue, and let's see what kind of conditional statement that I want to start. So since we started a rule, and you'll notice up here it is our rib type, I'm wanting to set up a particular rule that is going to control our rib display. So with that, I'm going to go ahead and start a conditional statement, and it's going to be a if-then, and you'll notice that we have different colors of our text. Now with the red that you see here, that is actually our condition. Okay. The next, the light brown color, that is where this is just a placeholder. This is where we're going to add in our parameter that our iLogic rule is going to be, you know, manipulating or possibly doing something. So for instance, for this one, I want to select my expression, and I am going to, let's see, on the model parameters, let's see if we have number of ribs. So what I'm saying here, if number of ribs, so I got to give it some kind of operator or operand between these. So I'm going to say something along the lines of if my number of ribs is less than or equal to 4, then I need to continue. So once this is met, so once my ribs, if it's less than or equal to 4 and that condition is met, I need to tell iLogic what is going to happen if that condition is met. So for this one, I'm wanting to say I'm going to have rib 1 and the rib 1 fillet, as you can notice here, I want those to be true, or I want those to be unsuppressed. I want to show on my model. So just like over here, since these are known as features, I can come over here to my features, over here in my snippets, and expand that. And I'm just wanting to let it know if these features are going to be active or not active. So you can notice here it's saying feature.isActive, and then you'll notice that I have an area in here that I just need to fill it in with the feature that I'm wanting to control. So we'll notice I have rib 1, and by me selecting these once, this is going to add it over here to our names tab window, and rib 1 fillet. So I'm just going to double click the feature name in the bottom, and I'm going to double click rib 1, and you'll notice that it has added it down here. So I want to say rib 1 equals true. And then I want to do the same thing for my rib 1 fillet. So the great thing is I can just copy and paste this line of code and add it right below that rib 1. And for this one, this is going to be the rib 1 fillet. Now, since I have rib 1 fillet and I want those to be active if my number of ribs are less than or equal to 4, I need to also tell Inventor what's going to happen to my rib 2 and rib 2 fillet. So if these are active, I don't want the rib 2 and rib 2 fillet active as well, where it's showing both of them. So I just need to set those two features to false. So I'm going to copy these 2 lines of code, and I'm going to come down and just do a paste, and I'm going to change rib 2 and rib 2 fillet, and then I'll go back and change those to false. So once I have that selected, I'm not wanting to continue too far before I check these, but there's one other thing that I need to do. So I have it right now that if my number of ribs is less than or equal to 4, I also need to continue my conditional statement and tell it, Inventor, what happens if my number of ribs is greater than 4. So I can continue this with another conditional statement here, and I can say else if then. And then once again, it is going to be my number of ribs. So I'm a big fan of copying and pasting. So if my number of ribs is greater than 4. Then for this design, maybe I'm wanting to make it to where rib 2 and the rib 2 fillet are true, so they're going to show on my model, and then rib 1 and rib 1 fillet will be false. So I can actually copy these 4 lines of code, and I'm just going to paste those down here at the bottom. Okay, so once I have that, you will notice here that for right now, for my rib type, this rule so far is looking pretty good. So what I'm wanting to do now is I'm just wanting to verify. Just like if we were flexing our model, I'm just wanting to make sure that we don't get any errors for the code that I have written thus far. So I'm going to say OK. So it looks like I didn't get an error telling me that any kind of issues are happening. So I just want to verify that the rib type rule is working correctly. So I'm going to go and I'm going to modify one of my parameters. So in here, the number of ribs, I'm going to make it greater than 4, and let's see what happens. And I'll move my model over just a little bit. Okay, so you'll notice by me being greater than 4, if I look over here in my model browser, you'll notice that rib 1 and rib 1 fillet has now become suppressed. And if we just go back to verify, okay, if we're back at the number of ribs, you'll notice now my rib 2 and rib 1 fillet are suppressed. So right now it looks like that my model is working correctly. So I'm going to go ahead and get out of my parameters dialog box. And now I want to go in and modify the rib type rule, because changes are required to the rib type rule to establish a further condition that controls the 2 rib configurations. Along with the rib number, rib activation must also be based on the flange's outer diameter. So you'll notice that if I want to go back and edit my rib type rule, over here in my iLogic browser, you can either double-click, that will launch the Edit Rule dialog box, or you can just right-click and choose Edit Rule. Now in here, I want to set up a condition that if my number of ribs is less than or equal to 4, and also my flange underscore OD is less than or equal to 60, then we're going to have some other things that are happening here. So you can either pull down, you'll notice possibly, keywords or operators from the drop down, or you can directly type these in. So I can choose and then for our user parameter of flange OD, I'm going to add that. So and our flange OD is less than or equal to, let's say, 60. Then I want it to continue where rib 1 fillet is true, rib 2 and rib to fillet is false. And I'm going to go down and I'm going to add another conditional statement in here that tells me more or less if my number of ribs is less than or equal to 4 and my flange OD is greater than 60, then we're going to go through and set up some conditions on which features are active. So what I can do is let's copy this section here. Okay, and I'm going to modify this area. So I'm going to say else if number of ribs is less than or equal to 4 and flange OD, I'll just copy that, and flange OD is greater than 60, then I want rib 1 and rib 1 fillet, I want both of those to be false, as what is showing here. And then also we're going to leave rib 2 and rib 2 fillet true. So you can see what's happening here. We've seen what happened whenever I had the number of ribs, if it was less than or equal to 4, what that was doing. But now I've just added another parameter to this condition that needs to be met to, activate or suppress or unsuppress these features here below. So I'm just verifying real quick that I got everything in my rib type rule correct. So false, false, true, true, false, false, true, true. Okay, so I'm going to click OK just to verify that everything is working correctly. Now, like I said before, we're wanting to check our rule to make sure everything's working. So here, I'm going to modify my flange outer diameter, or OD, to 80 millimeters. Okay, and I'm going to change the number of ribs to 4. Okay, so with the code that I've written so far, it looks like it is reacting as I am intending for it to. So I'm going to also change my value to 60. Then you'll notice with that flange outer diameter, you'll notice that it's changed the rib type. Okay, continuing on with the design criteria, we also needed to be able to control the display of the fillets. Okay, so this is the reason that we're wanting to suppress this is just like what I mentioned earlier, is possibly if we want to get this model ready for some type of analysis. So we possibly don't need some of these real small fillets that we have going on. So here I need to add another user parameter, but I'm going to change the type. I'm going to add a true false. This is just telling me whether, if something's going to be suppressed or not suppressed. So I'm going to name this one analysis. And by me having this as a true false, this is what is known as a Boolean parameter. And I'm going to go ahead and set it for false. Currently, we don't have any relationship for this user parameter attached to anything else. So currently, this parameter is doing nothing. So we need to link this parameter. So I'm going to continue, and I'm going to add another rule. And for this one, I'm going to call it, let's say, analysis. And I'm ready to go ahead and start my conditional statement here. So I'm going to do a if-then statement. And for this one, we're going to go to my user parameters because we're wanting to utilize that analysis parameter that I just created. So for instance, so if my analysis, and let's go ahead and, so we got two options. It's either true or false. So I'm going to go ahead and say if my analysis equals true, then we are going to set it up as I want the rib1 fillet to be false. So once again, rib1 fillet, that is a feature. So here, rib1 fillet. Okay. And so if my analysis equals true, I want rib1 fillet to be false. I want this fillet to be suppressed. So to continue with these, because I'm going to end up copying and pasting this line of code here, I'm wanting all of my fillets. You'll notice that I have a rib1, rib2, inner flange, and outer flange fillet on my model. So I'm going to set all of those features to false. And I'm just doing a standard copy and paste. So a rib1 fillet, rib2 fillet, inner flange, and outer flange, just so I can add them over here in my names window. And you can notice that I'm just highlighting my feature down here below and just double clicking on the one that I want to replace it. So we got rib1, rib2, inner, outer flange, fillet, and they are all set to false. Okay. So once we have that, we want to actually, let's say if I wanted to add a message box. So if, for instance, someone was coming in behind me and they had set that analysis to true and they couldn't really pinpoint what was going on, well, it'd make it easier if I had a message box that would pop up letting them know what just happened. So we can do that. So over here in my snippets, if I go over here to message box, let me minimize that one, you'll notice here that I can show a message box here. So this little snippet of code is messagebox.show, and you'll notice once again inside the parentheses, I'm just filling in the blanks. So with the message, let's say I want to enter something like fillets have been removed from the model to prepare it for analysis. Okay, and then for the title, let's enter something like, how about analysis preparation? Okay. So once I have that, we notice that if my analysis is true, all these fillets are going to be turned off or suppressed. And then currently I'm going to have a message box that has the title of analysis preparation with the message showing fillets have been removed from the model to prepare it for analysis. All right, so I have created my conditional statement so far for true, but within that analysis, you know, I set it up as a true or false. So now I need to go in and take care of what happens if my analysis is false. So I'm going to continue my statement, and let's change it to start it with the else if then. Okay, of course, it is going to be analysis once again. That is the parameter. And I'm just going to set it to, if that equals false, then I want all of my fillets to be true. So just a simple copy and paste. Okay. Now once we have this, for this parameter, this is completed so far with what I'm wanting to happen. So I'm going to verify this and make sure once again we don't get any errors. Now you'll notice that once I did this, both ribs are now visible. Okay. The reason that this has happened is that the program states that if analysis is false, which is the current situation, all fillets are displayed. So in order to show rib 2 fillet, the rib 2 feature must be displayed. So it has been automatically unsuppressed. All right, so I'm going to need to go in and we're going to need to do a little tweaking to my analysis rule. Now, the great thing that can assist us is we can actually go in and we can comment out certain lines. And what this does is this just helps us troubleshoot our code. Okay. So let's see what I want here. I want to select the 2 is active function lines that set rib 1 fillet and rib 2 fillet as visible. Okay. So let's see here. Rib 1 fillet, rib 2 fillet as true. Okay. And let's comment these out. So you'll notice here I got this comments out the selected lines, and then this just uncomments the selected lines. So you'll notice whenever I comment these out, notice that they are grayed out. So these are not currently included in our rule. Okay, so once I have those commented out, I'm going to insert an empty or another empty line right after those commented out lines of code. And what I'm wanting to do is I'm going to possibly need to run the rib type rule before my is active of the inner and outer flange. So for this, I'm going to type in, let's say, let's do run other, and then you'll see here that I can select run rule. So you'll notice now iLogic VB.run rule. So I'm wanting to tell this analysis rule that if my analysis equals false, I want it to then run my rib type rule and then continue with the conditional statements of turning on my inner and outer flange. Okay, so we'll notice, so my rib type, and we'll go up here and we'll look at, let's say, run other rule name. And it's one thing that you have to remember whenever you are typing in or referencing any type of model or user parameter or even features. They are case sensitive. So as you see them in the parameter dialog box or as you see them over here in your model browser, they need to be spelled exactly the same. So for instance, this one I need to have it where it says rib underscore type with a capital R and capital T. Okay, and I'm just going to get rid of this space here. Okay, rib type. Okay, that looks good. So currently, whenever I say OK, we're going to see what happens to these extra ribs that I have currently on my flange. There we go. So that cleaned that part of it up. Now, what I can do to keep my code all nice and neat, so within the analysis rule, we'll notice that I have commented some things out. So I knew that those were the problems there. So what I can do to keep everything tidy is I can go ahead and delete these two commented out lines. Just keep everything nice and neat. Okay, the next step that we need to do is within our design criteria, we had something that mentioned model I properties change depending on the material selection. So we're going to add a parameter that provides a list of 2 material types that can be assigned to the model. In using this parameter, we're going to create a rule that updates the model's I properties based on the material selection. So once again, I'm going to need to go in and we're going to have to add another parameter. And for this one, it's going to be text. And I'm going to give this the name of material, and I'm going to go ahead and make this a multi-value because I want to set this up for mild steel and stainless steel. Okay, and you can notice so I have my little drop down dialog that we have here. Okay, so once I have those, I'm going to go ahead and close out of my parameters, and once again I need to link that user parameter. So I'm going to utilize iLogic once again and create a new rule, and I'm going to call this one material, and we're going to start out with our conditional statement of if then end if. Now one thing that I haven't pointed out as of yet is with these conditional statements, if you start with an if, you need to make sure that you end with a end if, just so Inventor knows that you are done with that argument, and if you have any more that maybe needed to continue down here, it would know where to stop and where to start another one. So here we are going to go back. I'm going to select my user parameters, and we're going to replace that my expression with material. And we're going to, so we got two choices that we had, or we added to that multi-value, either mild steel or stainless steel. So we need to set up this iLogic code that what's going to happen if either one of those are selected. So for this one, I'm going to put in if material equals mild steel, then, so since my material, if we are familiar with where to find, the properties of a material, for instance, in Inventor, if we went to the iProperties of our part and went to the physical tab. So if we'll notice over here to the left, you'll notice that I have a iProperties section. Okay, and then also here we got a snippet called material. So now, if my material is mild steel, then my iProperties dot material is going to equal, let's say, steel, comma, mild. Now, you're going to notice that this was the value that I gave for my multi-value list, and then you'll notice here, if you've picked up, that now it's steel, comma, mild. Reason being, let me go ahead and say OK here, is the case sensitivity that I mentioned. So for mild steel, you'll notice in my materials drop down, it is spelled as steel, comma, mild. So you need to pay attention to, if you are referencing materials or anything like that that Inventor already has built in, that you have it spelled out exactly how Inventor does. Okay. So once I have that, I also possibly, since I was looking over here at my iProperties, maybe I wanted to go ahead and fill out my part number and stock number when a certain material is selected, which we can do with no problem. So what I'm going to end up doing is, let's say, you'll notice now that it's iProperties and it's pulling a material, but I want to also pull something like part number. Now, whenever I do this, this is going to end up being a value. Okay? So I'm going to go down to the next line, and we're going to click on part number. But let's break this code down a little bit more. So it's going into my iProperties. It's going to pull a value. Notice here it says project and then part number. Okay. So for instance, so I can show you where this is pulling from. So it is an iProperty. It is in my projects tab, and then you'll notice for this parameter, that is where we are going to have this to automatically fill in that part number for us, and then also the stock number. Okay, so it's just filling in the blanks. So I am going to my project tab, and then I'm wanting to fill in the field for part number, and I'm just going to tell it what I want it to populate that field with. So let's give it something along the lines of FL for flange, and I'll do MS for mild steel, and I'm going to go ahead and add those. And then just to give a number, I'm going to call this 1, 2, 3. Okay. So once we have that, so everything is working out good so far, I also want to capture or fill in for my stock number. So I'm just going to copy this and modify it just a little bit. So I'm going, within iProperties, Project tab. So instead of part number, I'm wanting to fill in stock number. And we'll just call this, just to give it something different, I'll call it MS for mild steel, and we'll just call this 321. Okay. So currently, I've met my conditional statement so far for mild steel, so now I need to continue down and tell Inventor what's going to happen if I have stainless steel. Okay, so we're going to continue with an else if, and I'm going to copy majority of this. Okay, so we know on my drop down that I did name it stainless steel. Now, if you ever run into a situation that you forgot, how you spelled certain things when you were typing these out, if I go to my user parameters here, and if I hover over one of my parameters, you'll notice the little tooltip that it kind of gives me there. So there to show you how you've spelled it. So you can see there, mild steel and stainless steel. Okay. And then, you know, for my OD that we utilized earlier, there's my multi-value for my flange OD. Just in case, you know, you might have forgot and you didn't want to get out of the edit rule dialog box. That's just a good little tip to cut out on some of the going in and out of dialogues. Okay. So I got, let's see, stainless steel. And for stainless steel, let's see what happens here. I think this one is just stainless steel. So that's the way Inventor recognizes that material. And I am going to give this a part number and stock number, but I'm going to modify it just a little bit. So this is flange, and we'll do SS for stainless steel, and SS here for the stock number. Okay. Now I'm going to take this one step further. I'm going to assign a line of code that controls the part color between mild steel and stainless steel. So we're going to, I want to give some kind of function that controls the color for mild steel here. So if I go to my iProperties, we're going to notice that I have a function for part color. And I'm going to set this one up as, let's just set this one up for black. Okay. And then for the stainless steel, I'm just going to give it a color of gray. All right, so once we have that, okay, and verify everything works. Okay, you'll notice that my part automatically changed colors. Okay, that was because before I assigned that iLogic code for material, I had it set to mild steel. Now also what I want to do is I want to go into my iProperties and verify that my part number and stock number also updated. And you'll notice here it did. So you'll notice at the top I have steel mild, so I have flange mild steel 123, and then my stock number is mild steel 321. Okay, so now I'm sure everyone's familiar with setting key parameters within your parameters dialog box. This is just certain things that I can go ahead and set as key, so I don't have to worry about possibly anybody coming in behind me and changing any of these other parameters. So they don't need to be, you know, changed at all. So I'm going to set my number of ribs as a key parameter, and then also the 3 user parameters that we set up. And then once I have those key, I'm just going to filter it to show only keyed. Okay, I'll make this just a little bit smaller. I'm going to go through and I'm going to modify some of my parameters just to make sure that my model is behaving as expected. So let's see what I get if I have 5 ribs. and my OD 70. Analysis might be kind of hard to see on your end, but I'm going to change my analysis to true just to see if I get that dialog box to pop up. And we do. Here's the message box. Here's the title that I gave it, Analysis Preparation. And then, of course, here's the message. Fillets have been removed from the model to prepare it for analysis. So I'm going to say OK. Just let me know what happened. And then let's go through and make a couple other. So it's always a good idea to test. 50. Analysis is false. Mild steel. You'll notice that my ribs have updated. And let's see one more. And let's change this to 8. 70 false. And let's change it to stainless steel. And it looks like everything's working exactly as I intended it. Now, one other thing, so since all that's working correctly, I want to be able to create a trigger. Okay? Now, a trigger is more or less enables you to define when a rule runs. And we're going to notice that if I go into, notice up here again, this is where we've been working at today. If I go into event triggers, you can see that we have, I can set a trigger where a particular rule will run on, new document, after open document, before save document, so on and so forth. So I'm wanting to, let's see, I want to create a, let's say a trigger that will run the material rule if a change is made to the material of the model. And just remember, the available materials for our flange are only stainless steel and mild steel. Okay? So before I do that, we're going to go in here to the iProperties and then into the Physical tab. And I'm going to see what happens if I change it. What if I change it to something like gold? And I'm going to hit apply. Remember, I only wanted for this particular part to either be stainless steel or mild steel, so you notice that I was able to come in here and change my material to gold. And possibly I don't want that to happen. Okay. So what we need to do is I'm going to go back into my event triggers, and I am going to add, let me drag this over, I'm going to add the material rule. So this is showing our rules over here to the right, or rules in this document. And I'm going to select, let's say, how about, let's just do material change. Oh, let me unselect that. Material change, select the rule. Okay. and that's the one that I want to run. So I'm going to say OK. You'll notice that that rule was added below this trigger. So I'm going to say OK. Now whenever I go back in here, I'm going to come down and I'm going to change my material here this time. So let's just say if I want to change it to, I don't know, nylon. Notice what happened. It now will always return back to the stainless steel material type. So to change the materials now, I must go through my parameters to actually change the material. So let's just see what happens if I try to change it again. Notice here, so I'm going to go in and update my properties. Okay. And everything's working accordingly. Okay. So as you can see, how even though this was a simple part, how we could add intelligence by utilizing the iLogic capabilities of Inventor. So that covers the part aspect of it. And I'm wanting to hit on the assembly level and the drawing just real quickly because I know we're starting to run out of time. But I've chosen some simple models to show you guys some of the capabilities. So next, what we're wanting to open is, let me jump back to my PowerPoint here. Okay, so assembly design using iLogic. Now, for instance, I want to also give you an example of utilizing iLogic at the assembly level. So in this example, iLogic is used to control the configuration of a screwdriver assembly. So the rule that controls the geometry sets parameter values in the screwdriver body part and sets the screwdriver cap and screwdriver bit components as suppressed or visible along with their associated constraints. In addition, for two of the variations, the rule indicates the version of the screwdriver cap eye part that is to be used. Okay, so whenever I go to and talk about the general steps of creating a logical assembly, you're going to notice that they're kind of the same as in regards to the general steps with creating a part. So number one is we need to prepare the assembly. You know, that means, once again, is ensuring that everything, all the dimensions, everything's working as we want. Then, of course, the creation of the assembly, just making sure that everything is placed and fully constrained. If we need to rename any constraints in the model browser, we need to go ahead and make sure that that's taken care of. And then also the naming of any kind of eye parts that are going to be used in our top level assembly. Those need to be taken care of as well. And then, of course, this is where we get back in to create rules in the assembly components. So possibly if you have, you know, some individual parts that you have created rules for or need to create rules, just make sure that those are already set up. And then at the top level of your assembly, we want to create any necessary rules. And then, of course, verifying the rules, setting event triggers like we did previously, and, of course, editing any rules or creating any additional rules as necessary. Now, for this one, this is going to be our goal. We're going to build a logical assembly model, and we're wanting to, create some iLogic that will create a configurable vice assembly that will meet the following criteria. So I'm wanting to have a small vice that you can see here that I've gotten some information already that this is the length of the base and the screw. And I also need to have the ability for a medium-sized vise, and you can see the dimensions needed for that configuration. And then also for the large vise. And then you'll notice the only parameters that we are changing is just the length of the base and screw. So those are the only ones that we're going to utilize within this assembly. Okay, so let me go ahead and give me a second to launch that model. Okay, so since we're getting short on time, I chose the one that I have already set up, the rule here, but we're going to talk through it real quick because I do want to utilize this model and take you into the drawing environment. Now, the first thing that we wanted to do, and I'm going back to my general steps, is just to ensure that everything is prepared in regards to my components. So you'll notice that we were controlling the base length and the screw length. So I'm going to go in and look at each one of these here. So we'll see that my vice screw, I'm going to go ahead and open this. And I'm just going to check some parameters. So we're going to notice here, so I have a parameter set up here, and it's just been renamed. So it was automatically one of our model parameters. So we'll notice that, so this is one of the parameters that we're going to utilize. And then I'm also just going to double check the base of my vise. Okay, and here as well, it was a model parameter that was just renamed. So we can see that we have that there. Now, I'm going to go ahead and close out of this. So it looks like I have my needed parameters to control this vise. So I'm going to go up and we're going to look at once again, we would need to also set up any parameters also in the assembly level. So you'll notice here that I have a multi-value of small, medium, and large. Okay, the next step, once we have our model set up with the intended parameters needed, then of course we go into creating a rule. So you'll notice that I have created a rule that is known as vice_size. And if I come in here and look, we'll notice that for this particular one, I have added in, just a comment letting you know what this iLogic code does. So if you're having trouble reading that, it's kind of a really faint gray. It says, controls the size of the base, vise, and vise screw components for varying sizes of vise. So you'll notice here that I have set up a conditional statement stating that if vise size, okay, so that would have been my user parameter, equals small, it was just one of my multi-values that I have given this parameter, equals, and these were some of the numbers that I knew that I had utilized to meet my design criteria. So for this, for example, if I go down to, let's say, my base vise and expand this, we're going to notice that I have model parameters here as well. So by double-clicking on this part parameter, because I am looking at the base_vise part, this will add this line of code here. So it's saying parameter within my base_vise 1, because if I look over in my model browser here, that is my component, then I am wanting to utilize the parameter of length_base, and then I'm just giving it a value. And I'm doing the same thing for the vise screw. So for the vise screw, I know that for this particular model, it is located under the screw sub assembly. So here, vise screw, digging down within my model browser to get to the part level here. And then we'll notice here, I got length_screw, and it's just breaking it down again. Okay, we're getting a parameter from the vise screw 1. That parameter is length screw, and then there's the value that we're telling it it needs to be. And the same thing continues going down to the large. Right. So once I have that, I'm just going to go through and just make sure everything's working as we intended it to. And we'll make this just a little bit smaller. And I could go ahead and just set that one as key if I wanted to. And that will only have one parameter showing here in my parameter dialog box. So I'm going to go to medium. So that looks like that's working okay. Possibly I've had to come in and, set up some kind of parameter to adjust my thread as needed. But for this demonstration, I was more concerned with, seeing the changes here happening on my lengths. So if I go to large, so you can notice that my base and my vise screw is updating. Okay, so I'm going to go back to small. And I'm going to go ahead and save this because we're actually going to use this to go into the drawing environment. All right. Okay, drawing creation using iLogic. First of all, let's talk about some of the rules that we have available. So, rules in a drawing document can automate many manual actions required when a drawing model is changed, such as controlling an active sheet size, also having the ability to control an active sheet's view placement, size, or scale, the ability to control an active sheet's title block or border. We can also set up some drawing rules that will reattach balloons to a drawing view. Possibly if you've gone in and changed the size of your model when you came back to your drawing, you've noticed that some of your balloons are everywhere on your document, so we can set up a drawing rule that can fix that for you. Also, the ability to control view suppression in an active drawing sheet, and also the ability to control the visibility of layers in an active drawing sheet. So just to go over the general steps of creating these drawing rules. One, of course, you can see that it's kind of following suit from part to assembly. So of course, prepare the drawing. Make sure you've got, everything set up as you would need it. Then we would go to the rule creation. Set up any kind of triggers that were necessary. And then, of course, edit the rules or create them as needed. So for this one, since I'm going to utilize this model, I'm going to go ahead and open up my vise. And let's make sure, got it, there it is. Okay. Now, let me make sure, go ahead and tell you what we're going to end up doing here. So we are going to create an iLogic drawing rule that controls the placement of the views on the drawing and also which title block and border are displayed. Okay, so we're possibly going to find out that when we go in and start changing the size of this model, that it might not fit on our page, or it might have some things overlapping. So we're going to take care of that. Okay. So here, I'm going to go in and I'm just going to investigate some things here. We know that in our vise assembly, we know that we have rules that drive the size of the base vise and the vise screw. Okay, because we just created those. So for this one, we know that my current size is small. I'm going to go ahead and change this to medium. Okay, and let's go back and let's see what happened to my drawing. So see, we're starting to get some of our model running off of the page. Now we're going to return back, and let's see how it does whenever I change my model to large. Okay, it looks like we got a lot of overlapping and also our model running off of the page. So what I want to end up doing is, let's go ahead and clean this up. So I'm going to change it back to small. Just verifying that my drawing updated as well. Okay, and it did. So I need to go in now, and I need to create a drawing rule to position and scale views based on specific conditions. Okay, so I'm going to do that at the drawing level here in the drawing file. So once again, I'm going to create a new rule. And for instance, how about I call this one something like drawing cleanup. Okay. Now, once I am in here, I'm going to go ahead, because once you start getting into writing iLogic code and you have writing a lot of code, it's nice to go in and put in some kind of comment or something that can help anyone coming behind you on what your code does. So I'm going to go ahead, and I can just start this out with an apostrophe there. And I'm going to put in controls, view scale, and positioning for sheet 1. Something like that. Okay. So now I can go ahead and start setting in some of my rules or conditions that I need to add. So what I'm wanting to do right now is, we'll notice that my drawing is currently only a single sheet. So I'm going to add a code that is only going to pertain to this current sheet that I have open. So if I go to and expand over here in my snippets section, you'll notice that I have a drawing area here. So I'm wanting to tell it that I want to activate a sheet. So you'll notice here I have activate a sheet. So it's saying this drawing or this sheet, and you're going to notice that it says sheet 2. But we know, since I only have one sheet, that I need to modify that. So I can type it in, or I can activate it up here in my model and grab the name. Either way. Okay, so I'm going to say for sheet 1, and then also I know in a later task I need a conditional statement that is used that requires reading data in the drawing model. So the drawing model name must be identified in this rule. So we're going to go down for this one. I'm going to go down and look at the Advanced Drawing API, and I'm going to double click on document name. Model document name. Where are we at? There we go. Okay. So here it's just going to allow us to where I can get, information from another document or model. Okay. So now I'm ready to start my conditional statement. So here I'm going to actually replace my expression with a statement that reads device underscore size parameter value. Okay. So if parameter, let's go in here and let's find it. So let's say device 1 and my model name. So I'm going to choose here, and then also we're going to choose device size parameter. Okay, there we go, my expression, device size parameter. So we'll notice that I have my if parameter, and then we have my model that I'm pulling from, the device size, and we have two choices or three choices in there, large, medium, and small. So I need to go ahead and say what happens if those are selected. So I got a small, and I'm just going to copy those down. And that's going to end up being an else if then. And I'll just modify these once I get them copy and pasted. Whoops. I did it again. Okay, small. Then I know I have a medium, and then also a large. And then just remember, case sensitivity. We've got to pay attention to that while we're referencing these parameters and features or parts. So just remember that when you're actually typing these in, if you're not selecting them from up here at the top, whether in your parameters area or your names window. Okay, so once I have that, I'm going to go ahead and say OK, just to verify that I'm not getting any errors so far. Okay, so far so good. Okay, so I'm going to go back in and we're going to continue adding or modifying this rule. So I'm going to go ahead and start out with my medium. So what I'm going to end up doing is I need to start setting, scales, where it's located in relation to my sheet, spacing from corners. So that would be if I go and look at my drawing node, you can see all the different snippets that I have available to me. So for this one, I'm going to go ahead and add a snippet of view scale. So here we have that. And also, I'm going to go ahead and let's say for this one, it's view 1. Now you would need to know which views these are. So for instance, let's see if I comment this out just real quickly. We'll notice here, that's my view 1, view 2, 3, and 4. So 1, 2, 3, 4. So on view 1 here, I'm going to uncomment that. So I'm going to tell it if within this active sheet, my view 1, the scale is, and for this particular one, I know a scale that will fit nicely on this page. So I'm going to say a scale of 1. And I'm going to copy this and continue down. And we might only have time for me to modify this one, but we'll see. So here I'm going to make this one 3/4, and I can add fractions in here. That's fine. And then also I need to set the center. Okay, so that's in regards to my X and Y. So that's back in my drawing, and it is view set center. So you'll notice here that I have to give it a value of X and Y. So for this one, I know that 7 from my X and 6. And then these are certain things that you would have to play around with to get them to work correctly on your sheet. But once you get them set, then you don't have to worry about it again if your model changes. And then also, I'm going to set distance from, I'm going to set a spacing to corner. And I'm going to set this one as, let's say, set center and view from corner. Okay. Now, some of these I do need to modify. So for instance, this one here that I set as 3/4 scale, that's actually going to be my view 4. So that little isometric view that I have up in the top right. And then also, let's say down here, I want to set that view from my specific corner, and I'm actually going to set that view's distance from the top right. So here, I'm going to go ahead and set that as 0.5. Distance from the Y, I'll set that as 0.5. And this will be just modify top left to top right. Like so. Okay. So I'm going to just click OK to make sure I don't have any errors. Okay. No errors, so that's good. Okay, now if you remember whenever I had the medium, I had some of this, my in view, or this view and this view, to where it's hanging off just a little bit. So I'm just going to modify these real quick to add the others. So here, just going to go copy and paste. And for the small, scales 1 and 1, and I know that for this one 6 and 6, and we'll leave that from the top right corner. And then continuing down for my large, I want to set my scale here. It's going to be a little bit smaller, 3/4, 7 and 6, right? Okay. So once I have those set, I'm going to go ahead and test my model. I'm going to go back and change it to the large. We're going to come back over here. Now we can see that it didn't update. That's okay. I just haven't set up any kind of rule that would automatically run. But just to verify that it does run, I'm going to right click on my rule over here in my iLogic browser, and I'm going to run the rule. And we can notice that I still have a little bit of overlapping. So what this needs to end up being is I'm going to fix that real quick with adding another line of code. And down here at the bottom, I am going to set my spacing. Instead of from a corner, I'm going to do between. So for instance, I can click on, let's say within my drawing, I'm going to use the snippet of spacing to other view. Okay. And you'll notice what I get here. So for this one, it is going to be view 2, spacing between view 1. Okay, I'm okay with that. And I'm going to change this to 2. And let's see, my active sheet for this one is going to be view 3. And spacing between view 1, and I'm going to make this a 1/2 inch. Okay. Now, the one thing I want to point out when setting the spacing between views, the first view name will move, and the second view name is the one being used as the measuring reference. So this view's one's just going to move. This one's going to be utilized as the reference. Okay, so once I have that, I'm going to go in and see if I need to add any others just to clean it up. And you know what? I do recall for this vise, I'm just going to go ahead and set them up for my small and medium. And for this one, to spacing between those views there, change that to 1. And for my medium, 2, and 0.5 should work fine for that one. So you can notice once I finish that rule, notice how my model here updated to stop the overlap between my isometric and this view here. Okay. Now, of course, I can go back and I can, modify and double check, but I do know that once I have done that these rules will update as needed. So we'll just change it to the medium. We know the small will work. Okay, and there's the medium. Everything is nice and clean, spaced accordingly to how I set it up in my iLogic rule. Okay, now I know we are right at time, so what we want to, I'm just going to change this or edit this real quickly. So the only thing that I'm wanting to do is between those sizes, possibly I'm wanting to add some kind of rule that will control my title block. Okay, so by doing that, let's do, I'm going to need to pull information from a resource file. Okay, and for this one, I'm going to modify this rule real quick. It's only a couple lines of code anyway. And I'm wanting to add a line of code between here for my resource file. So we got 1, 2, 3, 4. Okay. And I'm going to, in my drawing node, so since we're in my drawing, you can notice that we're staying here. So I'm going to choose a resource file name. Okay. So we're going to pull some information from another file. So here, I'm actually going to modify this to read generic template. So we're just going to pull something just from one of our templates. Generic, I need a space, template.idw. Now, what I want to do is, whenever I'm pulling information over from that template, is if any information in that template is not being used, then I don't want to keep it. So, for instance, if there were a lot of blocks in that drawing and I was referencing this, if I'm not utilizing those blocks, then I don't want those to stay in my current drawing. So I'm going to set up a little rule here that only keeps more or less referenced, or extra resources from those that are actually being used. So for this one, you're going to notice I can choose keep extra resources, and then by the default it's saying false, and that is actually what I want. Okay, so moving down here in the small configurations conditional statement, I'm going to add another line of code right above, and let's make sure I'm going to put this in the right place. Here, I need to tell it to which title block I'm wanting to use. Okay? So here, we're going to select, let me change title block. Okay? And for this one, since I'm going to use one of the defaults, it's going to be ANSI large, or actually, yeah, ANSI large. Okay. So that's what's going to be used whenever I choose small. I'm also going to add a border for this. Border. Okay. And I'm just telling it, the names of the title block and the border. So for this one, it's going to be default border. And now it's just a copy and paste, and I'm going to add this same thing here to the medium. Default border. Okay, that looks good. Okay, for this one, since I'm going to be referencing another file, and let me make sure, yep, it's going to be that generic template. We're going to actually, for this one, there we go. So we're going to have ANSI large for my, I'm sorry, it's actually going to be main title block. So I'll call this main title block. And also let's call this, and I might need, I want to use my C border. Okay. So I'm going to say OK and see if I get any errors, which I did not. Now, since this title block and border is the same on the small and medium, I'm going to change it to large real quick and see if my changes take effect for that specific setting. So large, and let's see what we get. Okay, I'm going to run my drawing cleanup rule. And there we have it. You'll notice here my border changed, and then also my title block, which is my C border or C title block. And you're going to see we got a nice little logo in here that I set up for generic. So with that being said, that concludes. I know we ran over just a little bit, but I wanted to at least get through that so we could start out at the part and then continue all the way through the drawing environment. And once again, I'd like to thank everyone for joining us today. Now, before we end today, is there any questions that you guys might have? And if you have any, you can just type them in within the GoToTraining chat section, and we'd be more than glad to answer those questions for you. Okay. Now, before I hand it back over to Laura, I just wanted to share a few links with everyone in case you wanted to, or if you get a chance to go and take a look at these. One is, of course, the Autodesk Inventor help, and you can see the link there. There's a lot of information out there, and it's continually growing every day. You'll be able to find, more information on iLogic, and then also, a couple tutorials that you would be able to, download some data sets and work through those tutorials step by step. Also, Autodesk has a YouTube channel, which is great. If you go out there and take a look at that, you can pretty much search for about anything in regards to Autodesk, from if you are using other softwares other than Inventor. Those are available for you to take a look at. And then one other website that I'm a fan of is called Being Inventive. And it's just a site that I go and reference from time to time, and so I just thought I'd throw these into the presentation today. Just if you didn't know about these, just check them out if you get a chance. Okay, with that being said, I'm actually going to turn the webinar back over to Laura.
All right, thank you, Jason. And dear LiveLab learners, thank you so much for taking the time to join us today. We hope you found this webinar informative and enjoyable. And please look for an email from us very soon with the link to this recorded version of this webinar for future reference, or if you want to share it with your colleagues, you could do so too. For a complete schedule of upcoming and future webinars, tidbits, and hands-on Autodesk training classes, please visit our website at livelablearning.com. And for special offers and exclusive LiveLab content, please be sure to like us on Facebook at facebook.com/livelablearning. And please take a look at on the screen right now, Autodesk Simulation Overview webinar that's also free for you to attend. And we have a 3D printing and scanning overview and to give you some latest scoops on 3D printing and scanning. And with that, we'd like to thank you again for your support to LiveLab Learning, and we will see you next time. Have a good day.